Hi, this is Tom, and in this lesson we are going to be solving exponential equations with matching base. So let's just get started right off the bat with some examples. So our first one is this: solve 4 raised to the x equals 1 over 128. Well, so if we look at this problem, somehow we're going to have to look at this a bit. Somehow 4 and 128 have the same base. Now let's take a look at how. For example, notice, let's do one step right off the bat. Notice that if I have 4 raised to the x equals 1 over 128, I can write 128 as 128 raised to the negative 1. So let's start with that, and then we're going to move forward here and play with a couple ideas. The first one is let's start multiplying by 4, for example. So if I multiply by 4, then the 4 to the first, let's try this. 4 to the first is 4. 4 squared, well, that's 16. 4 cubed, that's 64. So let's try again. We're trying to see if 4 will get us to 128. 4 to the fourth, well, that means, remember, that means 64 times another 4. Well, that's 256. So we skipped 128. So base 4 isn't going to work. So is there another base that we can use for 4? And the answer is yes, because 4 is the same as 2 squared. So we can write 4 in base 2. So this is 4 in base 2. So then the question is, well, can you write 128 in base 2? Well, let's try that too. So I'm going to write, let's start with 2. Well, we know 2 to the first is 2, and we already said that 2 squared is 4. So the next one is 2 cubed, and that's 8. Then we might look at 2 to the fourth. That's our next one. That's 16. 2 to the fifth. That's 32. 2 to the sixth. That's 64. And then 2 to the seventh power is, remember, we're getting big here, so I'm going to write these out. 64 times 2, well, let's see, 2 times 60, that's 120, plus an additional 2 times 4, there it is. So in other words, 128 is the same as 2 to the 7th power. So now that we know these two pieces, that's a weird way to highlight that. That 128 is this 2 to the 7th is 2 to the 7th in base 2, and that 4 is 2 squared in base 2. Now we can solve the problem. Let's see how. So I'm going to bring down my next step again. Let's just copy this so we keep it together. 128 to the negative 1. And now let's replace each of these with the appropriate base. So let's do that. Replace with base 2. Okay, so this is 2 squared. The 4 becomes 2 squared raised to the x. The 128, that's 2 to the 7th to the negative 1. And then recall that an exponent raised to an exponent, that's 2 to the 2x. And on the right-hand side, we have 7 times negative 1, so this becomes 2 to the negative 7. Now, since the bases match, this is key here, since bases match, solve by setting exponents to equal to each other. Solving by setting exponents equal to each other. And I started the sentence here with since, but you might also want to write once bases match, because you can't do that until the bases match. So then we'd say, in math, we would right now we can just say that 2x is, I'm sorry, yeah, oops, that 2x, not 2 to the x, but the 2x is equal to the negative 7. And we solve this, divide both sides by 2, so our answer is x equals negative 7 halves. And that's how we can solve an exponential equation, one in which where the bases match. Now, soon we'll be learning what happens if they don't match, but let's try them when they do. I think one more example is in order. So let's try this one. I'll leave that there. We're going to solve 125, wow, that's big, raised to the x plus 1 equals 625 raised to the x. Wow, not even sure where to start. So they both end in 5, and the rule of 5s is if a number ends in 5 or 0, it's divisible by 5. So I wonder if we could write 125 and 625 in base 5. So let's check. Notice if I have 5 to the first, that's 5. If I take 5 and square it, I get 25. Let's try cubing that. So 5 cubed, remember that's going to take the 25 that we have right before and multiply it by 5 again. That's 125. Oh, there's our first match. There, let's try again. Maybe we'll get another one. Let's try 5 to the fourth. Well, remember, that's 125 times another 5. And if you have your calculator, you can verify that, in fact, that is 625. So we want to write both of these in base 5. And if I draw a little colored arrow, notice that the 125 is the 5 cubed, and the 625 is 5 to the fourth power. All right, so let's proceed now. So I'm going to rewrite the equation now as 5 cubed raised to the x plus 1 equals 5 to the fourth raised to the x. Now, we have an exponent raised to an exponent on both sides of the equation, so we multiply exponents. So let's write that down, multiply exponents. Now, let's see, so this becomes 5 raised to the, now here's the key, this 3 has to be distributed through the x plus 1. So this is 5 raised to the 3x plus 3. And on the right side, we have 5 raised to the 4x. And now, since our bases match, we can solve directly with the exponents. So we say 3x plus 3 has to equal 4x. And then I'm going to subtract 3x from both sides. And now I have 3 equals x. And there it is. There's our answer. X equals 3. And we can always verify our solution by putting it back into our initial equations. So that's how we solve exponential equations when we can write them with matching bases. Thanks for watching.